Hari Om. In this session, we discuss Eddy currents. This is an effect produced by electromagnetic induction. Now, here an experimental setup is made that the north pole of the magnet and south pole of the magnet is kept some distance apart, and I am suspending a metallic sheet in between the magnetic poles. As it states like that, there is no effect at all. If I pull this sheet and release it, as the sheet starts oscillating to and fro, we can find that as it starts, initially it starts actually, and then the motion of this oscillation will be faster and come to rest all of a sudden. That means the oscillation of the metal sheet between the magnet is getting affected by the magnetic field, and that oscillation is getting damped and come to rest all of a sudden. And this damping of this metallic sheet is due to electromagnetic induction there. As it starts oscillating between the magnetic poles, the magnetic flux linked with the metallic sheet is changing, and thereby a current is induced in this one, and that current will be of the form of circles. Circular currents are induced in that metallic sheet. And that circular currents appears to be a whirlpool-like and eddying, we say, and those currents are termed as eddy currents. So eddy currents are the circular currents induced in a metallic sheet when it is subjected to a varying magnetic field. And this effect was discovered by Foucault, and this current is also called Foucault current. And actually these eddy currents are finding many applications there in the practical life, that you can refer the text and find out. But how these currents are being produced in the thick metallic sheet is due to the free electrons present. Those electrons, as I said earlier, the magnetic Lorentz force is making that to move in cyclic path, as it is subjected to a varying metallic sheet. Now, how to minimize this Foucault current? Actually, it is relating with electromagnetic induction, and you know that in the electromagnetic induction, phi is causing all the problem. That is, magnetic flux linkage is making all the problem. So this magnetic flux is linking with the area that you introduce in the field. So here also the thick metallic sheet is having an area A. If you reduce that area, reduce the area of the sheet, we can reduce the eddy current effect. Means instead of taking a plain metallic sheet, if I take a sheet with cuts in between like this, if I take a sheet like this, these strips, this open strip, thereby the area is being minimized, and therefore if you use this type of a metallic sheet, then the eddy current effect is found to be minimal. Okay? So this circular currents induced in a thick metallic sheet when it is subjected to a varying magnetic field is called eddy current or Foucault current. Applications are many, like in the case of what you say, using the damping effect, you can use it in the case of deadbeat galvanometer. Oscillation can be stopped all of a sudden. Then locomotive brake system. Then an induction furnace. If you require a high temperature for melting metals and all that, we use induction furnace. In that, this kind of currents are created for getting the large amount of heat. So like this, many applications you can find for the eddy currents.